All right, hello physics class. This is the beginning of week 5 out of 6 of distance learning. It's Tuesday, May the 26th, day 63. This week we're going to continue the study of waves. Last week we talked about light waves and optics. This week we're going to talk about a couple that relate to the Earth that you've heard of. One is earthquake waves and the other is tsunami waves, ocean waves, specifically tsunami waves. And then we'll finish up the week by talking about sound waves, and I'll introduce you to a nice little program that you might want to download if you're capable of doing that with your computer, and we'll play with that a little bit. Okay, so we'll go ahead and get started with the subject of earthquake waves. I'm going to show you a couple of short YouTube videos, one dealing with earthquake waves themselves, the other dealing with how scientists study earthquakes and how they study how to make buildings safer and more resistant from earthquakes.
The motion we feel on the surface of the Earth during an earthquake comes from energy released deep within the Earth. This energy is transmitted to the surface by earthquake waves. The study of earthquakes and earthquake waves is called seismology. Earthquakes occur when rocks deep underground suddenly break under pressure or slip along a fault. The point of release is known as the focus of the earthquake. The energy released by the earthquake radiates from the focus as body waves. There are two types of body waves. The fastest wave is called a P wave, or primary wave. It moves between 4 to 7 kilometers per second, depending on the density of the rock it's moving through. A P wave is a compression type wave. Rocky material in its direction of travel compresses, then expands as the wave passes. A P wave is similar to a wave traveling through a spring. The coils compress and expand in the direction the wave is traveling. The second type of body wave is called an S wave, or secondary wave. It travels at about 2 to 5 kilometers per second through rock, about half the speed of a P wave. An S wave is a transverse shear wave. Rocky material in its path moves up and down, or side to side, perpendicular to the direction of the wave's travel. An S wave is similar to a wave traveling along a piece of rope. The wave moves along the rope by moving a section of the rope up, then down. Surface waves radiate outward from the epicenter, the point on the surface closest to the focus. Surface waves are slower than body waves, traveling at 2 to 3 kilometers per second. They can change the surface of the Earth as well as damage homes, buildings, and other structures. There are two types of surface waves. A love wave causes side-to-side motion perpendicular to its direction of travel. It can cause damage by breaking roads and pipes. The second type of surface wave is called a Rayleigh wave. It moves the surface of the Earth up, forward, down, and back in a circle. It can cause damage by knocking buildings off their foundations. In most earthquakes, combinations of love and Rayleigh waves cause the most destruction because the ground shakes up and down and side to side at the same time.
Okay, so I've asked you some brief questions about those 4 types of waves. You'll notice that even though we're talking about earthquakes, the waves were of the type that we talked about 2 weeks ago when we talked about waves in general. The P waves were compression waves. They're like sound waves or spring waves. They move, they compress and release back and forth. And the S waves are transverse waves. They move like a roller coaster. And so you saw an example of both of those types of waves there. Okay, so go ahead and answer the questions on your assignment sheet. I'm going to show you one more short video. And this is filmed here in San Diego. This is research that's done at UCSD, where they actually build full-size buildings and put them on a table that shakes them to simulate earthquakes. So let's go ahead and watch this.
This 7-story structure is about to undergo the ultimate building inspection, a simulated earthquake. On the largest shake table in the U.S., University of California, San Diego researchers reproduce quakes to evaluate safer engineering designs and find new ways to make older buildings stronger. This footage is from the table's very first test back in 2005. The building was subjected to mechanical shakes that copied the ground motions recorded during the 1994 Northridge earthquake that rocked LA.
It takes a signal that it has been created artificially or is one that has been recorded from the ground motion anywhere in the world, and then we can reproduce the movement of the ground with extreme fidelity.
That means engineers can recreate actual earthquakes. Some of these include the 1989 quake that struck the San Francisco Bay Area, as well as the deadly 1978 earthquake in Tabas, Iran, that measured 7.8 on the Richter scale and lasted 3 minutes. Basically, the table is like a crash test for buildings, and Restrepo and his colleagues are coming up with new engineering techniques to better help buildings and their occupants survive these head-on collisions with Mother Nature. One design is using interior cables modeled after a push puppet. Those little toys where a segmented cartoon character falls down with the push of a button at the toy's base. Let the button go and the puppet springs back up.
The advantage of those things is that these buildings basically dislocate themselves.
Of course, the building doesn't collapse like the puppet does, but just moves enough that the rigid steel and concrete of the structure wouldn't bear the entire brunt of the quake's force.
And then when the earthquake fades off, they just settle back to where they were before.
While these engineering feats can help with new buildings, for older or historic structures that need retrofitting, engineers use everything from reinforced concrete casting to advanced composite materials and synthetic fibers. UCSD researchers are sharing data and information with earthquake-prone places all over the world. Keeping these new designs affordable is a major hurdle, and it's not the only one.
The biggest challenges that we face in future for earthquake design are for very strong, long-duration earthquakes. And by those we expect not in California, but perhaps in Washington and Oregon. The duration of an earthquake, the effective duration that is just ratcheting and on and on and on and on. We know so little that the things that we have developed so far may be okay. We hope they are okay, but we need to test them.
For Discovery News, I'm Jorge Rivas.
All right. So those are your 2 videos for today. Some of the closed captioning was spelling terms wrong. I think in the first video they spelled transverse wave as transfer wave or something like that. So some of the spellings aren't correct, but hopefully you got something out of that. So go ahead and complete the assignment sheet. This is due on Monday, June the 1st. And some of you need to catch up on some assignments. The good news is you got time, but you got to get going right now. So I'll be in touch with some of you to be sure that you're not going to fail my class. And some students have actually already finished the class with a grade of an A. They've gotten all the assignments done up until now, and they are done. Hopefully more of you will be joining them. Anyway, this is you have a good day, and we'll talk to you on a new assignment tomorrow.